Okay, welcome to the first episode of my apprenticeship series that I have been working on. Don't mind the dog's noise in the background. This is the first lesson that I'll be going into. We're just going to start off with electrical, get the hard ones out of the way, and then we'll move on to more fun things from that. I know this can be a bit dry, but please stick around. I will have some questions at the end for you guys to fill out, some workbooks, and I'll be showing the answers. And hopefully you guys can take something away from this and apply it to your careers. So let's get started. Okay, welcome to our first episode, part of the series. Our apprenticeship guide here. We're diving straight in with some electrical. Let's get the hard stuff out of the way first. Now, before we begin, I figure it's important to let you guys know that I did terrible in school. I did not take physics, and I passed with like a 54%. So if I can figure this out, you guys can too. You're going to have to stick with me. We're going to try and get as much theory out of the way as possible, but at the same time, I want this to be as detailed as possible and as educational as possible for people who are trying to get into the trade, as this is where the trade's going. So, as you can see on the screen here, I've got a whole bunch of little doodles here. I promise it'll make sense. Just let me go over it. So the first thing that I need to cover today is the basic math of electricity, and that is what's known as Ohm's law. So I've drawn this little pyramid here. It's easy to remember, but the gist of this is as follows. Voltage is always equal to amps times ohms, right? So if we know that amps times ohms equals volts, well, that means volts divided by amps equals ohms, volts divided by ohms equals amps. So using that logic, we can understand the math behind electricity, and we can figure it out. So to start, we've got a basic system here. We're only going to be covering DC. There's no reason really to get into AC. But this is, let's say, a 12 volt. Ooh, it's hard to draw with a mouse. A 12 volt standard system that you would see, let's say, a headlight. So we got ourselves our little light bulb here. Whoop. And of course, we have our switch. So as it stands right now, electricity flows to the switch. And because the switch is open, nothing happens. But as soon as that switch closes, there's the eraser there. Electricity can flow through, the light bulb can come on, and the circuit works. So we know that, we understand this. We've all seen it before. We turn on our headlight switch, headlights turn on. So something else that we probably will have seen before is you turn the headlights on and they're dim. And this is the basics of electrical diag. So the reason they're dim is we can refer back to Ohm's law here, is you have resistance somewhere in the circuit. Whether it's at a switch connector, at a bulb socket, or a bad ground, it can be somewhere in there. But let's just say we've got a green wire, because that's something pretty common that you'll see. So you've got resistance here. A very good point was brought up to me while I was reviewing this document, and I wasn't entirely clear. When I say green wire, I'm referring to the color of bronze wire changes after it's been exposed to moisture, and that color is green. So when I say green wire, I'm not referring to a physical green wire. I'm referring to corrosion that has happened inside a wire that has turned the color green. I just needed to clarify that, as there could be some confusion there. So what we've done now is we've added more resistance. Referring back to our first statement here, amps times ohms equals volts. So one thing's always constant with these circuits here. We always have 12 volts or 13.5 if you want to be technical, because you have them on while the vehicle is running. But for simple math, we're always going to be referring back to 12 volts. You can change it to 13.5 later if you want. I'm not that smart. So we're always going to refer back to 12 volts. So you close your switch, your headlights turn on, but they're dim. So now we're going back and we're going to start looking for things. So we've got 12 volts. If we've got 12 volts, let's just say this is 1 ohm of resistance. This is 1 ohm of resistance. So this is now what we would call a series circuit. So in a series circuit, you always add your resistances together. So 12 volts, 2 ohms of resistance, because it has to go through both to get there, which means we have 6 amps. Ooh, it's bad. let's just say it's a good wire, nothing happens. So we've got 12 volts. And what do we have before? We have 1 ohm of resistance. Let me fix that. Through the bulb. So again, referring back to volts divided by ohms equals amps. 12 volts, 1 amp means we've got to have, 12 volts, 1 ohm means we have to have 12 amps. So now this bulb is getting all 12 amps. So as you can see from something like that, when you have an extra line there, you've now half the amount of power that can go through. So this is something we call a series circuit. Now you'll see series circuits everywhere when you're working. I'm going to pull up a wiring diagram here. So as we can see here, we've got a series circuit. We've got a battery coming in to a starter motor and then to ground. So it's one line, one load, ground. Another one here. One line, fuse, load, grounds on the same side. Series circuit, series circuit. There's another type of circuit that you're going to run into in your industry here, and I'm going to make a more specific headlight circuit here, so give me a second. So this is something you'd see more often, right? You have your parallel circuit, which basically means you've got 2 loads in parallel. So again, you close the switch, load goes through, lights turn on, grounds out. We're not focusing on this today. I just need you guys to be aware that there is a parallel circuit. All we're focusing on right now is the series circuit up top, as that is something that you're more readily going to be dealing with. So just be aware that there is a parallel circuit, but series circuit's what we're wanting to focus on. So I'm just going to repeat everything that we just did, but in real life, so you can see how this all plays out in real life. So I've got a headlight bulb. This is just a breadboard. I'm using it to run my power. And I've got my battery source, and just because I couldn't find a shop switch, we're just going to pretend this is a switch, okay? So open and now closed. Closed. As you can see, the light turns on. Okay, so I'm going to let that go. So now referring back to that green wire here, I'm going to now add in a resistance on the power side of the bulb, just like we showed in the drawing. So just give me 30 seconds here to set that up. So I have now added a resistance. In this case it's a light bulb, but in most cases it'll be a green wire. So remember how bright that bulb was before? You just saw it. Here, I'm going to put a screenshot of it right now. That's it before. This is it after with that green wire in there. A little bit dimmer, huh? So the reason for that is because of that green wire. Now we're going to get into our second law of the evening. The second law is Watt's law. And Watt's law is volts times amps equals watts. So back to that drawing. So I have now redrawn our 2 circuits from before that I've now shown in real life, and now we're back into the MS Paint. And as I was saying, Watt's law, amps times volts equals watts. Power, in this case, bulb brightness. So with that first example we have, with just the 1 bulb straight through, 1 ohm total circuit, and referring to Ohm's law, 12 volts divided by 1 ohm equals 12 amps. And now referring to Watt's law, amps times volts equals power. So 12 times 12 is 144, right? So that's why we got such a bright bulb in that first one. Now that second one, where we had the second bulb, which was an example of a green wire, we have this math again. So 1 ohm plus 1 ohm equals 2 ohms total circuits, right? Referring back to Ohm's law, we have 6 amps because 12 divided by 2 equals 6. And now referring to Watt's law, we're going from 6 times 12 equals 72 total watts. So half of the other circuit. So as you can see in the video with the 2 bulb brightnesses, how just a little bit of resistance can really mess up an entire circuit, and it can start to do weird things. Okay, so key takeaways from this first lesson today is a quick crash course on Ohm's law and Watt's law. First thing, volts equals amps times ohms. Ohm's law. If you can remember that, and always reference back to that, you can usually figure out what's going on with the circuit. Second thing, watts is always equals to amps times volts. Watt's law. So it's the second thing to take away. And the third thing you need to take away here is resistance in a series circuit is added together for total circuit resistance. So now keeping that all in mind, we're going to start with our first question here. If you could just pause the video and figure it out, we'll be discussing the answer right away. So now that you've had some time to think about it, which bulb will be brighter, A, B, or C? So let's go into this really quickly. So I know I didn't put any ohm value here. I just don't want you to do math right now. I want you to look at it and I want you to realize how the circuit works. So A, you got 12 volts going through one bulb and then the ground. B is the first bulb and C is the second bulb. So looking at these, we know that A is the brightest for the following reason. If we're referring to each one as 1 ohm, 1, 1, and 1, as we were in the first examples when we started the course, as I demonstrated in real life, if you've got two bulbs or a resistance in a bulb in series, like we do here, each one requires power, so they'll be dim. So in this case, A would be the correct answer. So which bulb will be brighter? The answer is A. Let's get started on the second question. So this is the second question. Here I've broken out the calculator. Unfortunately, now we have to do some math. So I want you to calculate the total circuit resistance. I want to know what this bulb is. I want to know what the whole thing is, right? So the only information that I can give you is the circuit has 20 amps. So I'll give you a minute here to figure it out and then we'll discuss the answer. Okay, so now hopefully you paused that, you figured it out. So this is how you figure this one out. So we got 12 volts as is referenced by the battery here, right? And as I said, that's usually what we're going to be calculating is with 12 volts. So if we know that the circuit has 20 amps flowing through it, referring back to 12 ohms law, 12 volts divided by amps gives us the resistance, right? So the answer is 0.6. So that bulb right there is 0.6 ohms of resistance. So that's the answer to question 2. All right, here. So this is question 3, third and final question. So what is the total amps in this circuit? So I'll give you guys a second here to figure it out and then we'll go over the answer. So what is the total amps in this circuit? Again, referencing back to Ohm's law and a couple of things we went over. When you have a series circuit, which is all we've dealt with so far, you add your resistances together. So 1 and 2, 3, giving us a total resistance of 3 ohms. It's 3 ohms of resistance. And we know we have 12 volts. Again, referencing back to Ohm's law, if we've got 12 volts divided by 3 ohms, that equals 4 amps. So the answer to this is 4 amps. So that will be the end of episode 1 as far as electrical goes. So I'm going to start working now on my next one, which will be series parallel circuits, calculating series parallel circuits, how they operate in a car. I'm also going to be covering tools of the trade, multimeters, test lights, how to use them. And for the questions, we're going to start using some real world examples, using some things I've run into as a technician, some things that were taught to me, and use some real wiring diagrams so you guys can start getting used to seeing what you're going to be working with. So I hope you guys subscribe and I'll see you guys next time.